The Great Pyramid was constructed during the reign of Khufu around 2560 BCE. It was built by a centralized state with administrative control over labor, agriculture, mining, and transport. The project was not improvisation. It was organized national engineering. When completed, the pyramid did not resemble the rough-stepped structure visible today. It was encased in finely cut white limestone from Tura. The casing stones were polished and fitted with tight joints. The outer surface formed continuous smooth planes meeting at sharply defined edges. The structure rose to approximately 146 meters. The slope angle was deliberate and consistent. In direct sunlight, the surface reflected intensely. The monument was bright, geometric, and visually dominant across the Nile floodplain. It was not symbolic rough stone. It was finished stonework engineered to precise lines. The foundation was cut directly into bedrock. The base platform was leveled across more than 200 meters, using water as a horizontal reference. High points were removed. Depressions were filled. The result was a base plane with minimal deviation. This was required because any angular error at ground level would amplify vertically. The builders fixed the geometry first and then repeated it course by course. The structure consists of approximately 2.3 million blocks. Most core blocks weigh between 2 and 3 tons. The total mass approaches 6 million tons. That mass was moved without wheels under load, without iron tools, and without powered machinery. The governing limitation was physical force. Quarrying limestone with copper chisels and dolerite pounding stones sets a fixed production speed. Copper deforms under stress and requires constant reshaping. Tool maintenance was continuous. Metalworkers operated alongside quarry crews. Copper was mined in Sinai through state-organized expeditions. Ore extraction, smelting, and casting were all required before tools even reached Giza. Fuel for smelting required charcoal production. Charcoal production required wood. High-quality timber was imported from the Levant. The construction site depended on distant resource zones. Granite used in the king's chamber and relieving chambers was quarried in Aswan. Granite extraction required repeated impact with harder stone tools. The blocks were shaped, transported to the Nile, loaded onto barges, and floated north. River transport was the most energy-efficient stage of the process. Water displacement carries weight. Once on land at Giza, mechanical effort resumed. Transport across land was executed using wooden sledges. The coefficient of friction between sledge runners and sand determines pulling force. Dry sand increases resistance. Moist sand reduces it by maintaining compaction ahead of the sled. Workers controlled surface conditions deliberately. A typical 2.5-ton block required a coordinated pulling team. Human muscle output has strict biological limits. Sustained pulling capacity defined daily movement capacity. This was the central engineering constraint. Ramps converted vertical lift into horizontal drag. The slope angle could not exceed what teams could manage without stalling. If too steep, required force exceeded sustainable limits. If too shallow, ramp length and material demand increased excessively. The builders selected ramp gradients consistent with human pulling capacity. As elevation increased, ramp systems were modified to maintain workable geometry. Stone was not hoisted vertically by cranes. It was dragged incrementally upward. Placement required lever systems. A block was positioned, lifted slightly with wooden levers, packed beneath and adjusted until stable. Precision was achieved by incremental correction. Surveyors checked alignment and level constantly. Once the first courses were fixed, the pyramid's geometry replicated upward without deviation. The internal chamber system demonstrates controlled load management. Stone performs well under compression and poorly under tension. The granite beams above the burial chamber redirect vertical load away from a flat ceiling surface. The relieving chambers distribute weight laterally into surrounding mass. This prevents tensile fracture. The design is structurally rational and based entirely on material behavior. Food supply was fundamental to the operation. Thousands of workers required steady caloric intake. Grain grown in the Nile Valley was collected through taxation and redistributed to labor crews. Bread and beer formed the caloric base. Archaeological evidence from the worker settlement at Giza shows large-scale bakeries and breweries. Animal bones indicate regular meat consumption. The workforce was provisioned deliberately because muscle output directly determined construction speed. Labor organization was structured. Crews operated under supervision. Seasonal labor from farming communities supplemented permanent skilled workers during Nile flood periods when agricultural fields were submerged. The flood cycle synchronized workforce availability with transport conditions. High water levels improved river shipping efficiency. The state integrated environmental timing into project scheduling. Injury and tool failure were managed operational realities. Skeletal evidence shows healed fractures, indicating medical treatment. Rope fibers, wooden sledges, and copper tools were replaced or repaired routinely. Preventive maintenance preserved consistent work rates. The largest engineering limitation was sustained stone movement under human power. Quarry output, hauling capacity, ramp slope, tool durability, and worker endurance defined the pace. Increasing speed would require either harder tools, additional food supply to support more laborers, or steeper ramps beyond safe force limits. None of those variables could expand indefinitely. Construction duration reflects these fixed constraints. The Great Pyramid stands because its form channels gravity efficiently. The wide base spreads load across bedrock. Each course transfers compressive force downward. There are no structural elements dependent on tension for overall stability. The mass stabilizes itself through geometry. This is why the monument remains intact after more than 4 millennia. The project represents centralized resource control across Egypt. Copper from Sinai, granite from Aswan, limestone from local and Tura quarries, timber from the Levant, and grain from the Nile Valley converged at Giza. The pyramid is the physical result of that integrated system. It is not a mystery. It is a large-scale application of material knowledge, labor organization, and controlled force executed with consistency over decades.